Everyone, this is Derek, and this video is about finding the vertex of a parabola, and then we're also going to find X and Y intercepts and kind of determine orientation of the parabola. So pretty much I'm going to go through all this stuff on this sheet in this next problem, this example. Okay, so for the following equation, find the coordinates of the vertex, indicate whether the vertex is a high point or a low point. Also, that would be called a max or a min, which is what I'll likely refer to it as, and then the X and Y intercepts. So what we're given here is that the vertex of a parabola, again from standard form, is the negative b over 2a part of the quadratic formula. And so if you do negative b over 2a, just like you would for the quadratic formula, that gives you the x coordinate of the vertex. In other words, if I have some parabola opening like this, what it does is it gives me that x right there. So that equals negative b over 2a. And then from here, to get the y, what we do is we take that x, whatever that was, and we just put it back in the original function, and then that's going to tell me the y that goes with it. So here, for instance, if I knew x was 2, I would plug that back in and go, okay, and then y equaled whatever it equaled to go with that. So that's how we're going to find the vertex. If you have something that is a positive x squared, that's what this, if a is greater than 0, it's going to open up and you're going to have a minimum. If you have something that is less than 0, so negative, a negative x squared problem, that's going to open down and you're going to have a maximum. To find x-intercepts, so remember that's what we were just doing in the quadratic formula video. All we're doing is we're finding the zeros. So we're letting y equal 0 and then solving for the x equals 0s, and that's our intercepts. Likewise, to find a y-intercept, all we would do in that case is let x equal 0, and then if it's in standard form, the y-intercept is actually that c on the end. So let me show you that in the context of this problem right here. So for this one, we're going to do vertex first. So x equals negative b over 2a, and b is negative 6, so negative 6, I'll just write that as a 6, and then 2 times a is the invisible 1 in front of the x squared, so 6 over 2 would equal 3. And now I'm going to take that, plug it back in for x, and I'll get the y that goes with it. So y is 3 squared minus 6, 3 plus 8. So here we'll get y when x is 3. And that should be 9 plus 8 would be 17 minus 18, so I'll be negative 1. So that means I have a vertex at x is 3 and y is negative 1. Is it a high point or a low point? So x squared is positive. When we have x squared positive, that means it's smiling, it's opening up. So that means this is a low point or a min. To find the x and y intercepts, to find x-intercepts, we just let y equal 0. So I'll do x squared minus 6x plus 8 equals 0. And this factors easily, so I'm going to do that. X and x multiplies to 8 and then adds to be negative 6 will be minus 2 and minus 4. Those together, we would have x equals 2 and x equals 4 as our two x-intercepts. And then for the y-intercept, if I just let x equals 0, oops, doesn't equal 0, it equals y, then all that drops out and I have 8 equals y. So I'll have a y-intercept, let me write that as a coordinate, at when x is 0, y is 8. Likewise, these as coordinates are 2, 0, and 4, 0. You don't have to graph anything, but just to kind of put this together for what we just found, this is about to be a really terrible graph, but here it goes. Basically, we found our y-intercept up here was this 8, and then we had an x-intercept at 2, we had an x-intercept at 4, and then a vertex that would have been like at 3, clearly not drawn to scale, 1 or negative 1. So something about like that.